Hi guys, welcome to Satya. Now I am here with the part 4 of indefinite integration. We are done with the conceptual part of indefinite integration, and in this part I am going to say all the problems which are very important for all exams. Before seeing part 4, please check out part 3, part 2, part 1 to clear in the concepts. Okay guys, let's move to the first problem. I will give some time for doing this problem. Please try it. Okay, fine. I will solve it. As you know, all the expansions of cos, you know that cos 2x equals to 2 cos square x minus 1, right? If we bring this minus 1 to the opposite side, we will get 1 plus cos 2x, that is equals to 2 cos square x. Okay? Instead of this, we have to write 2 cos square x, and in place of x, we should write x by 2. Integration of 2 cos square. I say 2x is there, we will get x. I say 6x is there, that gets half and we get 3x here. I am taking 1 by 2 outside as 1 by 2 a constant. 1 by cos square is nothing but secant square. What is integration of secant? It's nothing but tan. Okay. 1 by 2 tan 3x, and we all have to remember that that's 3x is present, so we have to divide it by 3, and the final answer is 1 by 6 of tan 3x plus 3. Easy problem, right? The next problem. Coming to the second problem. Try to solve it. Okay, time up. We have done this type of problem in second part also. You can check it out. In this problem, we have to assume that x power 5 has t. Why only x power 5? Why can't x power 10? Because here you can see x power 4 in the numerator. As the differentiation of x power 5 is x power 4, we get 5x power 4, right? And this is the term we have here. So in place of this, we should write dt by 5. So the integral part becomes 1 by 5 of x power 5 is t. So here 1 plus x power 10. This can be written as x power 5 whole square, which is t square. Okay, 1 by 5. What is the integration of 1 by 1 plus t square? It's tan inverse of t. Tan inverse of t plus c. Okay, in place of t, what we have assumed, we should keep back in that. 1 by 5 tan inverse of x power 5 plus c. This is our final answer. Okay. Coming to the third problem. Integration of 6x plus 8 by 3x square plus 6x plus 2 dx. Think it for a while. Okay guys, I will say it. This is a bit complicated, and here one more chapter is involved in it. It is partial fractions. I think you have learned partial fraction in second year. Okay. what we do in partial fractions, the numerator can also be written as, or numerator should be taken as the differentiation of denominator, that is 3x square plus 6x plus 2 plus with a constant, some constant a plus b. 6x plus 8 equals to, what is the differentiation of this? 6x plus 6 plus b. 6x plus 8 equals to 6ax plus 6a plus b. By equating the coefficients of x and constant, we can get a and b. 6x plus 8 equals to, if we take x common, or 6ax plus 6a plus b. This is the constant and this is the coefficient of x. 6a is equals to 6. Equating the coefficient of x, 6 gets cancelled and we get a equals to 1. And equating the constants, 6a plus b equals to 8. As a is 1, we get b as 2. Okay, a is 1 and b is 2. That means the place of 6x plus 8, we can write 3x square plus 6x plus 2 plus, what is b? 2. Okay, it means this can be written as like that. Sorry, 6x plus 6, as a is 1 and b is 2. Means we have to expand this as integration of 6x plus 6 by 3x square plus 6x plus 2 plus 2 by 3x square plus 6x plus 2. I am assuming this as I1 and this as I2. As this is a big problem, first solving I1. Solving I1. I1 equals to integration of 6x plus 6 by 3x square plus 6x plus 2 dx. Okay, this is a function and its differentiation is in numerator. So if we take whole this as x and we get the numerator as its differential part, and I1 equals to, finally we get 1 by t if we assume this as t, and integration of 1 by t is log t. In place of t, again we have to substitute the denominator. So finally we get I1 equals to log of 3x square plus 6x plus 2. This is I1. Now solving I2. What is I2? 2 by 3x square plus 6x plus 2 dx. Okay. Here we have to take 3 common, as there should not be any constant before x square. So 2 by 3 integration of 1 by x square plus 2x plus 2 by 3. This is the thing we get after taking 3 common. And we have, by seeing this, we can understand that the further integral function will become in the form of 1 by x square plus something. Okay, x square plus a square or something. The third part, I have said all the important formulas of integrations. This is one of that. Please check it out. x square plus 2x. If we add plus 1 and subtract minus 1, we get a perfect square as x plus 1 whole square. Okay. Two by 3 of integration 1 by x plus 1 whole square minus 1 plus 2 by 3, it becomes minus 1 by 3, and 2 by 3 of integration 1 by x plus 1 whole square minus 1 by root 3 whole square. Can you write like this? Obvious, right? 1 by a square minus x square. What is 1 by a square minus x square? Integrations, it is 1 by a means 1 by root 3 log of a plus x by a minus x. This is I2. For writing combinedly, we get the final answer. I1 plus I2 is our final answer. I is equals to I1 plus I2. What we get? Further simplifying this, we get 2 by root 3 log of root 3 x plus 1 root 3 x plus root 3 plus 1 by root 3x plus root 3 minus 1 plus I1 log of 3x square plus 6x plus 2 plus c. This is the answer. Here comes the last problem. Integration of sine of ln y plus cos of ln y. Please try to do it. While solving it, you can learn a new concept or a new trick to integrate easily. Okay? I will do it. First of all, by seeing this, we will not get any idea of how to do this or but here they had given ln y. We should take ln y as a variable or t, and if you see here, what is the inverse of ln? It becomes exponential. Okay, we can write y is equals to e power t. Okay, this is the main step, and this is the problem changing step. Here if we differentiate, dy equals to, as differentiation of e power t is e power t only, it will not change, e power t dt. In place of dy, if we keep e power t dt, the function becomes e power t sin t plus cos t dt. As ln y is t, I have substituted ln y is t. Okay. Here, as I said in the part 3, we can do it by separately multiplying them, or there is a new trick. That's a small shortcut. You have to remember this. Anything if given like this, e power x into sin x or e power x into f of x plus f dash of x dx, then you can directly write the integration, and the final answer would be e power x into f of x plus c. This is a shortcut. And I don't think so. It is not too hard to remember. Okay. If you given the function in terms of like e power x into f of x plus f dash of x, if there is present a function and its derivative in the brackets, the direct answer will be e power x into f of x. Same as like this. See here, e power t into sin x If we assume that sin x as f of x and its sin x derivative is cos x, its derivative is present in the same bracket, so the final answer would be e power t into sin t plus c. Again substituting sin t, t. What is t? T is ln y, so e power ln y sin of ln y. E power ln, it becomes y into sin ln y plus c. Okay, and this is the answer. And I have given all the problems I have discussed in the description. And that's it for today. Thank you for watching. Please like, share and subscribe Satya channel. Thank you.